Hello everyone, my name is Pradeep and today I am going to discuss about EV motors and powertrain. If we talk about the EV motors and powertrain, so these are very crucial component in EVs that actually differentiate them from traditional internal combustion engine vehicle. In an electric vehicle, the powertrain is nothing but a system that actually generates and delivers power to the wheel. If we see the traditional vehicle that consists of traditional internal combustion engine, EV power train consist of the following components which are already mentioned like a EV traction motor, traction battery pack, DC-DC converter. So all these components belongs to the powertrain. If we talk about the architecture of the powertrain, so this is the generic architecture where we can see we have mechanical transmission, electric motor, and a vehicle controller, and DC-DC converter, etc. Depending on the number of motors or type of engine or control system has been used, the powertrain can be differentiated, and that we will discuss in the coming slide. This is a generic vehicle where we can see these are the list of components like transmission, electric traction motor, power inverter. All these kind of components are available in electric vehicle, and these are the part of the powertrain of the vehicle. If we talk about types of powertrain, so electric vehicle powertrains come in several different configuration, each with unique characteristics and benefit. If we talk about the battery electric vehicle, so battery electric vehicle is completely powered by electrical energy stored in the battery pack. BEV includes basically battery pack, electric motor, and inverter, and regenerative braking system. And this electric vehicle battery pack can be charged from the outsides. BEV offers zero emission, and it has a high efficiency and a very quiet and smooth operation. We have seen a number of vehicles like Tata Nexon, BYD vehicles. If these vehicle runs in the road, we can't hear any noise. So these vehicles are very noiseless. Then we have plug-in hybrid electric vehicle. So plug-in hybrid electric vehicle actually combines conventional internal combustion engine and battery electric vehicle component like battery pack and motor, etc. So its components are an ICE engine and electric motor, larger battery pack, inverter, and regenerative braking system. So basically, all components of battery electric vehicle plus ICE engine that makes them PHEV, plug-in hybrid electric vehicle. So plug-in means we can charge its battery from outside source. So this is the major difference between HEV and PHEV. So it can operate on electric power alone for shorter trips and switch to ICE for longer trips. So this actually provides greater flexibility to customer, and basically it helps in reducing the range anxiety. Then we have HEV. HEV is similar to PHEV. That is nothing but hybrid electric vehicle. The only difference is we cannot charge its battery pack from outside source. So its battery can be charged through regenerative braking and the IC engine, not from the any external source. Then we have one more powertrain system which I have not mentioned here, that is hydrogen fuel cell electric vehicle. We call it FCV. So in FCV, instead of battery packs, uh, hydrogen gas is used. Basically hydrogen fuel cell has been used, so we call it FCV as well. So FCV includes a hydrogen fuel cell, electric motor, and battery pack for additional power and storage, etc. So FCV is also similar to BEV, only that offers zero emission, and we can have the quick refueling, etc. But there is one problem with the FCV. Hydrogen refueling system are not available. Basically infrastructure for FCV is very limited. If we have the infrastructure, then hydrogen vehicle can be a game changer. These are the different examples of the powertrain. This is a MEB powertrain by Volkswagen. So it uses two motor system, to drive the front and rear wheels separately. Then we have the Jeptron powertrain platform by Tata Motors. Then this is a Tesla powertrain for Tesla vehicle. So Tesla has a different powertrain for different vehicles. Like this is a two motor power train, but Tesla has one motor powertrain, two motor powertrain, three motor, and four motor powertrain as well. So depending on the number of motors, powertrain system can be differentiated. This is a ether energy scooter powertrain. So here we have this mid drive motor and belt drive system to drive the wheel. So as mentioned earlier, depending on the number of motors which has been used in the electric vehicle, powertrain can be differentiated. So here in first image, one motor has been used to drive the all four wheel of the system. Here two motor has been used to drive front wheel. One motor has been used, and second motor for driving the rear wheel. Then in three motor system, one motor drives the front wheel and two motor drives the rear wheel separately. In the same way, we have four motor system. All wheels have separate motors for driving the vehicle. So depending on the number of motors uses, the basically control system becomes very complex. So how actually manufacturer decides how many motors we have here? It depends on the size of the vehicle, weight of the vehicle, and reliability and efficiency of the vehicle. If we have one motor, then definitely in that case the control system or control method will be very easy. But if we have four motor, then the controller needs to sync all the motors so that vehicle performs better. We have types of motor like DC motor, AC motors. DC motors are known for its robustness and easy to control, but have drawbacks like larger size, lower efficiency, and frequent maintenance need. So DC motors also comes with brushes, that mechanical brushes basically, and because of this it requires maintenance. Then we have AC motors. In AC motor we have brushless DC motor, synchronous motor, and induction motors, and these are the motors which has been used in EV industry very widely. So AC motors are preferred in EV because they are highly efficient and requires less maintenance and can recover during basically store energy during braking. These are the seven types of motor which has been used in the AV industry widely. One is brush DC motor, switch reluctance motor, synchronous reluctance motor, axial flux motor, IPMSM motor, and induction and BLDC motors. In coming slide, I am going to discuss about all these motors separately. Synchronous reluctance motor has been used in Tesla vehicle, and induction motors are also widely used in three-wheeler, two-wheeler, three-wheeler, and four-wheeler. In Tesla vehicle also, in initial days, Tesla vehicle also used an induction meter. So in the coming slide, we will discuss about the type of motor, their working principle, characteristics, and the structure basically, and their operating reason, like how actual motors works. To understand the operation of electric vehicle, it is crucial to first understand how exactly electric motor works. At the core of electric motor, we have two primary component. One is stator and one is rotor. In an EV motor, electric current flows through the stator. So stator has a number of windings. So in through these windings, current flows. And basically current flows, and stator is the stationary part in the motor. The current which is flowing in the windings, it actually generates a magnetic field in the stator, and the magnetic field interacts with the rotor. Basically rotor is nothing but the rotating part of the motor. So the magnetic field generated by the stator interacts with the rotating part of the motor, that is rotor, and this interaction actually causes the rotor to spin. Okay, so this is the basic principle how exactly motor works. As the stator remains stationary, the rotor rotation is what actually ultimately drives the motor. It is also helpful to distinguish between a motor and an engine. A motor actually converts electrical energy into mechanical energy, while an engine converts thermal energy mainly from combustion, so into mechanical energy. If we talk about the engine is a specific type of motor that uses thermal energy, but not all motors are engine. So in electric vehicle, the motor is key component that enables the vehicle to move. Okay, thank you.